Hi guys. So what we're going to start doing on Fridays is I'm going to start posting some videos and some extra assignments just for you guys who want to look a little bit past what we're currently doing in Algebra 2 and just get some early exposure to some things you may see further down the line. So one of those is going to be series and sequences. That's going to be kind of these next 3 Fridays videos. And then after that, we're going to get into just a little bit of trig stuff. So this is all stuff that will be covered in pre-cal, but we want to just go ahead and give you guys a little bit of exposure to it to kind of make that transition a little bit easier. Also, in case you guys are taking it over the summer, the series and sequence stuff, I'm not sure if that is covered in the Northlight course. It kind of depends, I think, on the teacher or how much time they have within it. So it may be good for you, those you guys who are taking over the summer, to see this. Series and sequences won't come back in AB calculus, but they will come back in BC calculus. So a little bit of early introduction could be helpful for you guys. All right, so we're going to start today with just kind of a big overview of what all these different things are. We're going to start with just a sequence. Okay, so a sequence is basically like a function, except the domain isn't everything. The domain is just going to be the natural numbers. So what that means is that sequence is defined by the term. Okay, so 1 is the first term, 3 is the second term, 5 is the third term, 7 is the fourth term, and 9 is the fifth term. So the term number we're going to say is n. Okay, a sub n is the notation we're going to use for that place in the sequence. And then you can substitute, so a sub 1 is the first term, a sub 2 is the second term, a sub 3 is the third term, and so on and so on. So what we need to do is write this sequence. Now, a really common mistake is just to say, look, I'm adding 2, so my sequence is n plus 2. Problem is that doesn't work, because if, let's say that was my sequence, if I plugged in 1 to get the first term, 1 plus 2 would be 3. Well, my first term is not 3, my first term is 1. If I plugged in 2, 2 plus 2 is 4. Again, that's not the second term in that sequence. So what this sequence actually is, this is basically a linear function. Now, what we're going to do the next 2 Fridays is we'll look at 2 specific types of sequences. One of them is going to be more linear, one of them is going to be more exponential, and we'll come up with some formulas to make it a little easier to write these. But for now, we can just kind of see how this is changing. This sequence would be 2n minus 1. Because if I plug in 1, 2 times 1 minus 1 is 1. 2 times 2 minus 1 is 3. Okay, if I want the fifth term, if I plug in 5, I would get 9, which is my fifth term. So what we're going to do to start is just given some sequences, find some specific terms. So if I want the first 4 terms, so a sub 1 is the notation for the first term. So I just plug in 1 for n. A sub 2 is the second term. A sub 3 is the third term. So 1 over 2 to the third is 1 over 8. Then the fourth term would be 1 over 16. What's nice about this type of sequence as well is you can find any term in that sequence. You don't have to go in order. I can skip all the way to the 100th term, and that would be 1 over 2 to the 100th power. All right, let's look at this next one. The first term, negative 1 to the first is negative 1. But the second term, negative 1 squared, is positive 1. The third term is negative 1. And the fourth term, again, negative 1 to an even power, is going to be a positive. So you notice it's kind of alternating this between negative and positive, negative and positive. So if I were to plug in 100, since that's an even number, that's going to be a positive 1. This next one's going to be pretty similar, except when I plug in 1 this time, that becomes negative 1 to the second, when negative 1 squared is a positive 1. So then if I plug in 2, that would be negative, positive, negative. So it's still alternating, but it's alternating in an opposite way. So the 100th term, if I plugged in 100, that would be negative 1 to the 101, which would be negative 1. All right, so now we're going to look at a specific type of sequence that's called a recursive sequence. So recursive sequence is a little bit different. What's nice about them is they could be a little bit easier to write if you can just see what the change is. What's harder about them, though, is if you want to find the 7th term, you have to know the terms before that in order to determine what it is, because the terms in a recursive sequence are based on the preceding terms. A really good example of a recursive sequence is the Fibonacci sequence, which is one you guys have probably seen before because you have to add those previous two numbers together. So looking at this sequence, we're given not only the sequence, but also the first term. You can't really have a recursive sequence without a starting term. Because the way we would read this, okay, let's say I want to find the second term. So a sub 2, well, I've plugged in 2 for this n. That means this would be a 2 minus 1 plus 3. So the second term is going to be the first term plus 3. Well, the first term is 1, so the second term is 1 plus 3, which is 4. Now I'm going to do the third term. The third term is going to be the second term plus 3. So 4 plus 3, which is 7. Okay, the fourth term would be the third term plus 3. So the fourth term would be 7 plus 3, which is 10. The fifth term, 10 plus 3, which is 13. So again, the problem with this is if I wanted to find the 100th term here, then I would have to find the 99th term, which means I'd have to find the 98th and 97th and so on. So these aren't good if you need to find a term that's really far down the road. All right, so the next thing we're going to move on to is summations. All right, so sometimes what we're going to do is we're going to find the partial sum of a sequence. So all that means is that we're going to add a certain number of terms in that sequence. So capital letter S stands for partial sum. The little subscript is the number of terms you're adding. So S1 means the sum of the first term. So really that just means the first term. Okay. S2 means the first term plus the second term. S3 means the sum of the first three terms. So term 1 plus term 2 plus term 3. So now let's actually find what those are. Well, let's find our terms. The first term, if I plug in 1, is 5. The second term is 7. And the third term is 9. So the first partial sum is 5. Second partial sum is 5 plus 7, which is 12. Third partial sum is 5 plus 7 plus 9, so 12 plus 9, which is 21. And those are our partial sums. All right, so then we're going to move on to probably the biggest thing from today, and that is sigma notation. So sigma notation is a way for us to not only do partial sums, but also to show infinite sums. And that's when we get into the idea of a series. And that's what you guys are going to look at when we get to geometric, which will be in about 2 weeks. But you'll also see this series concept come back up in BC calculus. So partial sums is just the sum of a set number of terms. But sometimes we can add these formulas forever and just have them go to infinity. And those are when we start introducing the idea of a series. So the way sigma notation works, right? Sigma notation basically means you're going to find a definitive answer. So like in this first example, this whole thing has one numerical answer equivalent. So the way it works, you have a sequence that's listed next to the sigma. What you're going to do is you're going to plug in term numbers, just like we've been doing. The number at the bottom is the first number that you plug into that sequence. Then you keep plugging in those integers until you've plugged in that last number, the top number. Once you've plugged in the top number, then you stop and you add all those terms up. So looking at this first one, I'm going to start by plugging in 4. So I'm going to do 2 times 4. Then I'm going to add the next term. So after 4, I would do 2 times 5. Then I would do 2 times 6, and I would keep going not until I get this number, because I already have that number. I need to plug in that number. So keep doing every integer until you've plugged in that top number. That looks like 2.8, not 2 times 8. And now I can add all these up. So 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20. Add them all up together and you get 98. So this whole sigma works out to just be 98. All right, looking at the next one. Plug in 3. So 3 squared plus 2 Then I'm going to plug in the next integer. So plug in 4. Then I'm going to plug in the next integer. And then I'm going to add them all up. So that's 9 plus 2, 16 plus 2, 25 plus 2. Which gives me 56. All right, so what we also can do is we can take something and write it in sigma notation. So in order to do that, we need to do two things. We need to figure out what terms we're looking at, and we also need to figure out the sequence, and that's the most important thing. So I'm going to start with my sigma, and then I need to come up first with the sequence that's being shown here. So if you look at this sequence, the 3 is not changing. What's changing is the exponent. All right, so that exponent is going up by 1 each time. So I'm going to write this sequence as 3 to the x. What's nice about sigma notation that makes it a little bit easier, with the number that you start with, it doesn't have to be 1. Now you can write it to where it is, but in this case, I can if I want this first term to be 3 to the third, I can just say x equals 3 at the bottom of that sigma. And then I keep plugging in those integers until the last number I plugged in is 20. So that's one possible way to write this. Now the thing that's nice though is there's more than one way to write this. Let's say I wanted to start with the first term. Well, now this would be 3 to the x plus 2, because 1 plus 2 gives me 3. And then I would keep going until I plugged in the number 18, because 18 plus 2 gives me my last term. Or another option, I could do 3 to the x plus 3, and I could start with 0 and end with 17. So a lot of possible options what you could use here to be able to rewrite this in sigma notation. All right, so that's it kind of for our intro. Today is really just kind of going over all the vocab for these things. There are some practice questions if you guys want to look at those as well. But basically the next Friday we'll look at a specific type of sequence in partial sum and we'll get some formulas for it. And then we'll look at another type the Friday after that.